A system in algebra. A system in algebra is indicated by a bracket. A system contains two or more equations that have one or more solutions in common. All right, two or more equations. So there's one equation. Here's the second equation. So two or more equations that have one or more solutions in common, where the solution would work in both equations no matter what. In order to solve that, this is a review day. You've learned all of this before in Algebra 1 and Algebra 2, but we're going to set the groundwork for the rest of what we're going to do in Chapter 7. Here are your three strategies that you've learned so far to solve these. We will cover a few more in another day, but here are the three we're going to do today. 1, there's a strategy called substitution. All right, substitution is when you choose a single variable to replace all other variables. So that's called substitution. We'll cover that. Second strategy is a strategy called elimination. That tends to be a favorite of people. Okay, elimination is where you combine the equations in such a way that you eliminate one of the variables. And the third strategy that we're going to cover today is the strategy of graphing. Right? And using graphing can be a helpful technique if the algebra gets really complicated. So if the algebra is easy, then substitution or elimination are the best ways. But if the algebra starts to require, heaven forbid, the quadratic formula or things like that, then graphing might be your way to go. All right, so we're going to look at this real easy problem that I've started. We're going to review how to do substitution. So let's look at this first system. It's got two equations, and we want to see what they have in common as a solution. So we've got x plus y equals 4, and we have x minus y equals 4. This problem is so easy that some of you might be able to figure out the problem in your head, that what you should put in for x and what you should put in for y, that would work out and give you both the answers 4 and 2. Some of you can do that mentally. You already know the answer. But we're going to go through the processes to review. Let's start with substitution. In substitution, you pick one variable that is the easiest, in your opinion, to get alone. All right, so as you're looking at that system, there are 4 variables to choose from, 2 x's and 2 y's, and you pick the one that you think is the easiest to get alone. What do you think? Okay, I heard votes for all of them, and that could be fine. Okay, my vote would be this x here in the second equation, because for me to get that alone means what do I have to do to both sides of that equation? Add y. And so x would be equal to 2 plus y. For me, that would just be the quickest thing I would do. Then what I would do with the substitution is I would take the substitution 2 plus y, and in the opposite equation that I didn't use, I would replace that x with 2 plus y. So this question becomes 2 plus y substituted, and then another y added onto it, equals 4, because in the equation equals 4, the 2 plus y is the substituting part, and then plus 4. All right, then we solve. 2 plus y is 2 plus 2y. That equals 4. I work on doing math to both sides to solve that. What am I going to do first? Subtract what? 2. Subtract 2. So 2y equals regular 2. What do I do to both sides next? Okay, I'm going to divide by 1. Okay, and we'll have our solution for y. A solution for y is part of the answer. It's half the answer. I think you should put that away. And you want to find the second part of the answer by substituting again. So you have to take the number 1 and plug it back up in for that y value right there. So that's going to give me x equals 2 plus 1, or 3. So now I have my solution value, which is 1 for y and 3 for x. So we write it like this. 1 for y and 3 for x is written 3 comma 1. What does that look like? A coordinate. Okay, it is. It's written intentionally to look like a coordinate. So that's an example of substitution. And some of you could have figured that out on your own. Let's check if it works back in that system. Okay, if I put 3 and 1 for x and y, 3 plus 1 works out to 4, 3 minus 1 works out to 2, so the answer is 3 and 1. Now, I'm going to do the same problem, but I want to show you the elimination method before we go to some more complicated ones. So same question. So we already know what the answer is. but I want to show you, just to review with you, how elimination works. All right, so we'll start over. X plus y equals 4 and x minus y equals 2. In order to do elimination, what you do is you line up the problem so that one variable cancels out another. This works great when you have one variable that's positive and one variable that's negative. So I can see right now that I've got a positive x and a negative y, which is a prime opportunity for me to do something called elimination. Elimination is also combination. So what you do is you combine these two equations into each other. And when you do that, what do the x's combine to make? And don't say x squared. Okay, 2x. And what do the y's combine to make? Nothing. They are eliminated, which is why we call this elimination. And then 4 and 2 combine to make 6, so we got 2x equals 6, which is an easy problem to solve and gets x equal to 3. So this is a very popular method. Okay, people tend to like elimination as an option. If x is 3, then you have to go back and substitute 3 back in to solve for the y value. It doesn't matter which equation you pick, top or bottom. So if I pick 3 plus y equals 4, if I pick the top equation, then again, y is equal to 1. So once again, my solution is x for 3 and y for 1. So I write it 3, 1. Now the reason we write it as a point is, what does that represent? The x and the y of what? Okay, what's right? What's happening at that point on the graph of a coordinate plane? Okay, it's an intersection. Okay, these two graphs. So this is where you'll need your graphing calculators. So this is the third method. So grab out your calculators. Okay, in a problem like this, where you have x plus y equals 4 and x minus y equals 2. In order to graph, what button do we use? Y equals. Okay, this problem is not ready to be graphed yet because it's not y equals format. So your job is to put it into y equals format. So what will the top equation be in y equals format? Not x minus 4, because there's my y, and I want to subtract x from both sides. So this will be 4 minus x, not x minus 4. How about the other equation if I want to get that into y equals format? What will that look like? How do I get that the easiest into y equals format? Because that y is negative right now. I want to add the y over to this side so it's positive. That's what I usually do, is add y onto both sides and then subtract the 2. So I'll have x minus 2. So in my graph, I'll have y1 and y2. So I'd like you to put that into your y equals, and then make sure before you hit graph that your window is set to the standard values of negative 10 to 10 for your x and max, and negative 10 to 10 for your y min and max. And then hit graph and take a look to confirm if the graph does indeed confirm that these two things intersect each other at the place where we've thought that they should. So you should have a y1 graph that's looking like that. You should have a y2 graph that comes up that way. And indeed, the intersection should be at the values of 3 and 1 to confirm everything. So tonight, your homework will say, solve it with this method and confirm it with graphing. So you do the algebra work, and then when it says confirm, this is what I want. It doesn't have to be on graph paper. You're not going to submit it in Canvas. You need to make a sketch on your paper of the directions of the lines and how they're intersecting at the point where you thought it was supposed to intersect. Okay? Now that was a very basic example. So we are going to move on to some other, a little more complicated examples, each of which has a little bit of twist. Any questions so far? All right, let's try another system. All right, so we'll work on something new now. All right, this system is going to be a 2-equation system again. Okay, so 3x plus 2y equals 14, and 1x minus 2y equals 10. Your choice of how you want to solve that. So suppose you are told substitution. Okay, what would be your goal is to pick a variable easiest to get alone. So what would be the variable easiest to get alone? All right, x, and so x would equal 10 plus 2y, which means in the other equation behind the 3, you would replace it, and it would go right in there. Okay, so that would be fine. That would be one way to do it. Okay, but if you had your choice, you might not pick substitution. What might you pick? Elimination. Why? It's lined up perfect for elimination. All right, elimination is these two things are lined up perfectly for that. So we combine. So elimination is really combination first. So we combine and we get 4x. We eliminate the y's altogether and we get 24. X turns out to be then 6. Based on x being 6, now you have to substitute into either of the equations, the top one or the bottom one, it would not matter, and take that value of 6 and plug it in. I'm going to use the bottom equation. So 6 for x minus 2y equals 10. Subtract 6 from both sides to get negative 2y equals 4. And divide so that y equals negative 2. So the solution is 6 for x, negative 2 for y, which means these two lines should intersect each other in quadrant 4 at the point 6, negative 2. We're not going to graph it right now, but if we did, that's what we should see. Okay, any questions on that elimination one? Okay. This is example 3 out of 4 examples. X squared, okay, so here's something we haven't seen yet. Plus 4x minus y equals 7. And 2x minus y equals negative 1. Okay, as you think about that, what method would you use and why? Use substitution. Okay, what would you get by itself? You would get which y? The top y or the bottom y? All right, so you'd get the bottom y by itself. What would that turn out to be, Greg, if you got the bottom y by itself?
So you subtract 2x, you get negative 1 minus 2x and divide by negative 1.
Okay.
1 plus 2x.
All right. What would you do with that 1 plus 2x? What would you have to be really careful about when you did that?
You have to put parentheses and distribute the negative.
All right, you have to put parentheses and distribute the negative. All of that is totally fine. Okay? Now, someone else may have said something different. You know what? I want to try elimination. Okay? And I'd say, okay. So x squared plus 4x minus y. And I'd say, well, what variable are you going to eliminate? Okay? They say, well, I want to eliminate the y. I'd say, well, you have a problem because both y's are negative. And they say back, oh, no worries. What can you do? All right, you are allowed, if you want to eliminate, multiply either equation by a constant number. And so, all right, maybe in elimination, then you want to multiply everything by negative 1. That changes the bottom equation to be negative 2x plus y equals 1. And I've lined it up in such a way that the common variables are lined up right beneath each other. Which you notice there's nothing beneath x squared. And that's fine. Elimination still works. You don't have to have a perfect match for all of the variables. You just have to have two variables that match up to eliminate. And so elimination might be a good way here. All right, when we line up our variables, all right, x squared, well, that doesn't, and then line up the x's and then the y's. And so we combine and we get x squared plus 2x. We eliminate the y's altogether and we end up with 8. Either way, whether you do Greg's way of substituting and you remember to distribute and all of that, either way you're going to end up with the same thing. You're going to write exactly where we're at right now. This is where you're going to be. So now your job is, no matter which method you use, you still end up with x squared plus 2x equals 8. How do you solve a squared problem? Okay, it has to be equal to what number on one side? It has to be equal to 0. This is not a time to use square roots. Do not do this. I'm just going to square root this and square root that and square root that, and then I'm going to be fine. You can't square root addition problems, so that would not be appropriate. The appropriate thing would be to set it equal to 0. And when you set it equal to 0 by subtracting 8 from both sides, it's a prime time to do the star because squares are, it is, which we're back to week 1 of school, okay? Week 1, back in August 15, we were sitting here doing star. So we're back to -8 and 2 being my options, and 4 and -2 being the star values. So I'm going to take those two star values of +4 and -2, and I'm going to split it down the center. And I'm going to take out the front common of x and x plus 4. The back half of it has a -2 in common, but also leaves me with x plus 4. So I recognize that x plus 4 is an important factor. It needs to be set equal to 0. And x minus 2 is an important factor. And it needs to be set equal to 0, which will give me x equals -4 and x equals +2 as different values for x. If I have two different values for x, I'm going to also have two different values for y. So I need to take each x value, plug it back in to the equation from the beginning. So I'm going to use the bottom equation, if you don't mind, since it doesn't have the square. So I'm going to have 2 times -4 for x minus y equals -1. That will give me -8 minus y equals -1. When I add 8 to both sides, I now have +7. And when I divide, I have -7. So a solution that works for this system is -4 and -7, which is in quadrant 3. So in just a moment, I'm going to graph this, and I expect to see it cross in quadrant 3. The other value, when I plug 2 back in to the same equation, I'll have 4 minus y equals -1. Subtract 4 from both sides. We'll get -5, so y must be +5. So my other solution is 2, 5, which I expect to see in quadrant 1. Okay, let's check this. I'd like to check this one, have everybody graph this one. So let's go back to the beginning. It's not ready to be graphed. I need to get y by itself in order to have this be ready to graph. So let's think about what we would need to do to have that happen. If you have x squared plus 4x minus y equal to 7, what's the quickest way to get y equals into that format? That wouldn't be the quickest for me. I would add y to the 7 side and then subtract the 7. So I'm going to have y equals x squared plus 4x subtracted 7. Can you tell me what it's going to look like without looking at a graphing calculator? It is a parabola. Squared things are good, so we're going to have should see a parabola. For the other equation, it was 2x minus y equals -1. So the quickest way for that is also to add y and then to add 1. So we're going to have 2x minus 1, or plus 1. So we should see a parabola intersected by a line, and the intersection points should happen in what two quadrants are we predicting? Look at where your solutions are. Which quadrants? This was 3, and this was 1. All right, I'm going to pause my recording. Could you please graph these and then turn your calculator around and show me that you've got the graph ready. All right, so we are seeing a linear line coming through the two quadrants, and cutting off actually part of quadrant 2, and then the parabola that came through here. And then I want you to just mark, and it can be a sketch, it doesn't have to be perfect, but mark those values. Okay, there's 2, 5, and here's -4, -7, which confirms, so everything matches. Your work matches your graph, and everything confirms that that was good. Okay, last example. So this system also will have a square in it. All right, and here's our final system. -x plus y equals the number 4, and x squared plus y equals the number 3. You can do either substitution or elimination here, depending on what your choice is. If you decide to eliminate, you need to make sure that you're lining them up correctly. So if you decide to eliminate, you're going to need to like spread things out a little bit so that the x squared is not lined up under the minus x, because those are not like terms. All right, so that would be my one caution of doing elimination, is that when you don't have matching terms for all of them, that there's no x in one to match the other, there's no x squared to match the other, you got to really be careful about that. So it might just be better to do substitution. You can get y alone very easily. Okay, if I get y alone, it would be 4 plus x, and then I can substitute that in right here. So you kind of have your choice of how you want to end up going. If we do substitution, we'll have x squared plus 4 plus x equals 3. And I want to set that equal to 0. So you end up with x squared plus x plus 1 equals 0. All right, so either way, either you've done elimination or you've done substitution and you get to this point. Both strategies will lead to the same. Now we're ready to star factor this again with 1 and 1. We've got 1 on the top and 1 on the bottom. And you know, half and half don't work because although they add to 1, they don't multiply to 1. 1 and 1 don't work. Although they multiply to 1, they don't add to 1. So if nothing works, then what do I need? I need the quadratic formula. So we'll have x equals negative b, which is negative 1, plus or minus the square root of b squared, 1 squared, minus 4ac, that's 4 times 1 times 1, all over 2a. So as we simplify, the solutions for x are plus or minus 1 minus 4 over 2. So negative 1 plus or minus rad negative 3 over 2. And it's been a little while since before Christmas, but rad negative 3 is I rad 3. Okay, which is imaginary. So it all is coming back. Well, what quadrant is an imaginary number in? Well, it's not. It's not graphing. So what does that mean about my graph? All right, go ahead and type both of these into your graph. In y equals format, I'll save you the time. y1 is 4 plus x. y2 is 3 minus x squared. Upside down parabola this time. Tell me what you see and how does it make sense with what we just did algebraically. What do you mean they don't intersect? They miss each other completely? All right, so when we look at the graph for this, we've got a parabola that's going upside down like this, but we have a line, that just barely misses it, and there are no intersection points. So the graph still confirms the algebra. The algebra said no solution. Okay, but what if you like second guess yourself? You're like, oh crud, would Mrs. Pfeiffer put no solution on the quiz? She wouldn't really do that, would she? So then you check the graph. And if you do see a solution on the graph, what does that mean happened in your algebra? You made a mistake. But if you don't see a solution on the graph, then you can feel a little more confident and not worry that you made a mistake in your algebra somewhere.